Okay, welcome to question 2. Determine the mass of a load which must be suspended from the lower end of a vertical copper wire of diameter 0.5 mm so that the extension is 0.1% of the original length of the wire. Given Young modulus for copper, this one. Okay, so what's the mass? Okay, what you want to find is the mass hanging on the copper wire. Okay, still the same case like before. Yeah, this is the copper wire and this is the mass hanging. Okay. Yeah, the diameter, given diameter, this is the diameter. Okay, in mm, we need to change to SI unit. Extension, this is the elongation, 0.1% of the original length. Okay, L naught. This is the L naught. Yeah. Careful. So this is the we want to find. This one is the L naught. Yeah. Give the percentage there. Young modulus given there. Okay, this is the Young modulus. Now, so this is the information given. Okay, I stated here. So the diameter is 0.5 mm. So you must change to meter. Okay, change to SI unit. So milli is -3. And then you give the extension 0.1% of the original length. This is how we write it. Yeah, 0.1% of original length. The Young modulus in Pascal. Okay, Pascal is SI unit. No need to bother. Now, first of all, for diameter, if the question gives you diameter, of course, you can straight away find the area. Yeah. For this chapter, when it give you diameter, no need to think. Just find the area. So for this copper wire, the area should be a circle. Okay, something like, yeah, it didn't say it's a square area or what shape. Yeah? If no shape is given, means by default is a circle. Okay, because we know that any wire must be in circle, isn't it? So is the wire is this one, yeah, this one. Okay, so we need to find this area. Already given the diameter, yeah, and this is the original length. Okay, L naught. First of all, we need to find the area. So the area is pi r square. When we substitute r equal to diameter over 2, when we substitute r equal to diameter over 2, when we square it, we get diameter square over 4, isn't it? We substitute diameter over 2 into the radius, we get pi area equal to pi d square over 4. So actually, you can just remember this formula. Area is pi d square over 4 or pi r square for what? For a circle. Okay. Now, let's straight away find the cross-section area. Yeah, this area. So let's find out. Yeah, let's find out. Don't waste our time. So just substitute the diameter. Okay, make sure it's SI unit. Yeah, SI unit. You substitute into the diameter, and what do you get? What I get is 1.9635. Please maintain at least 4 decimal place. 4 decimal place before arriving the final answer. When you reach the final answer, only you change to 2 decimal place. Okay. In the midway, you maintain 4 decimal place for accuracy. So okay, -7 meter square. So that's the cross section area. We got one. Okay. Now, give this extension 0.1% of the original length. That means we can change the percentage into fraction. Always change the percentage into fraction. When we see percentage, we change to fraction. So percent means divide by 100. Do you know that? Percent is actually divide by 100. It's actually per 100. Yeah. So remember, next time, the percent. Sorry, So that remember, next time the percent means it's 1 over 100. Okay. So percent is 1/100. Like that. Yeah. So 0.1 divided by 100 L0. That means what? Divide by 100. That means we go one space. Okay, we go one space. 1, 2. The top also 1, 2. That means over here. So that means become what? 1, 2. So add another. So add another 0 here. So point become here. So that means it is understand that? 0. That means it becomes 0.001 L0. Okay. Go by 2 0. Here also go by 2 0. So it's 0.001. 0.001 L0. 0.001 L0. Okay, that's the fraction. So from here we can further elaborate. Extension over L0. Okay, the L0 go below 0.001. Extension over L0 is actually what? Remember, extension over L0. What is extension over L0? Strain. That's the strain. Strain. Remember, strain has no unit. No unit because meter divided by meter. No unit. So we got the strain. Congratulations. Okay, so I got the strain already. Now, give you the Young modulus here. So I need to find the mass which is hanging. That means this is the mass the mass is pulling on the rod. The mass is pulling on the rod. So there is a tension. There is a force acting in the rod. So when you have force, you have stress, isn't it? Force over area, you have stress. So that means I have the Young modulus. Young modulus is stress over strain. I got the strain just now. So I can find, I also have the Young modulus. So I have the strain, I have the Young modulus, I can find the stress. And from the stress, I can find the force in the wire, which is the tension. When you have the tension, you can find the mass, which is hanging on the wire. Okay, so easy. So now let us do it. Finish our job, yeah? So I have a strain, I have a Young modulus, just put inside, plug in all the values. My Young modulus is 1.23 exponent 11. Exponent 11 equal to my strain, stress over strain 0.001. That's my strain. So let us find out what is our stress. What is our stress? 1.23 exponent 8 Pascal. Yes. You know that? Do you know that? The Young modulus unit is Pascal. The stress also Pascal. Okay? Stress is Pascal. Young modulus also Pascal. Why? Why they have the same unit? Because the strain has no unit. Strain has no unit, so it doesn't interrupt with the unit. So stress has the same unit as Young modulus. But they are not the same thing. They have same unit, but they are not the same thing. Yeah? They don't have the same meaning. They are different. So, this stress experienced by the rod is 1.23 exponent 8. I got the stress. Now, I want to find... okay. So, you see, the force in the wire is actually the tension. The force in the wire is actually the tension. Yeah? Force in the wire is a tension, and this thing is in equilibrium. So that means tension equal to mg. Yeah, you know why tension equal to mg? Because when acceleration equal to 0, total force equal to 0, isn't it? Total force equal to 0, that means T minus mg equal to 0, isn't it? Yeah, we put going above is positive, going below is negative. So T is positive, mg is negative. So T minus mg equal to 0. That means that's how we get mg go to the other side. So we have T equal to mg. So the tension equal to mg. First find out the tension. Oh, no. Okay. So the force in the wire is the tension, isn't it? So we can substitute force in the wire is the tension. Okay, force in the wire is the tension, and tension equal to mg. Tension is mg. Tension is mg. So now I have the stress. I have the stress in the wire, and also cross-section area. I also got it just now. So just plug in all the values, and then I can find the mass hanging. I can find the mass hanging. Very easy, isn't it? So this is 1.23. The stress is 1.23 exponent 8. And then mg, g is 9.81. And then the cross-section area just now is actually a circle, 1.9635 exponent negative 7. 1.9635 exponent negative 7. Is it? Yeah, correct. SI unit. All right. So I can get the mass. So my mass, I finally got 2.46 kilogram. That's the mass hanging on the rod, which bring this tension and this stress on the wire. Okay, 2.46 kilogram. Is that correct? Yes, 2.46 kilogram. So that's it. Yeah, very easy. So remember, when find cross-section area, by default, when no mention what area, normally it's a circle. And then the percentage is always per 100. Percentage means per 100. Per 100, change to fraction form. And then here you can find strain and apply the Young modulus formula. Young modulus is stress over strain. And then stress is a force over area. The force in the wire is always the tension. Okay, that's it. So see you in the next question. Bye.